Good morning to all. Okay, today we are going to discuss about stag and queue concept in data structures. So before entering into the topic, just we want to recall the previous topics about some in data structures. So already we known in the data structures there are two types. So that means linear and non-linear. So linear and non-linear data structures in we want to order the data in a two manner, that is a linear data structures or in a non-linear data structures. So what is the difference between them? So in a linear means the data elements can be arranged in linear fashion. So that means that the elements can be arranged in without any gap. Continuously we can allocate the memory for that elements at memory. Okay. So next, non-linear means the data elements can be arranged in memory in random fashion. That means some elements will be placed here and some elements will be placed here. So between this some gaps or any other elements can be placed. But these elements known which one will be comes after for us. So this is the random fashion. So this is the two types of data structures we already studied in the previous units. So now we want to study discuss in a detail for stag and queue. So in a stag and queue, the elements can be arranged in linear fashion. That means the data elements can be arranged in continuously, so without any gap. So then the elements can be arranged in continuous manner means in which concept can be used to implement this stag and queue. So in a basic concept we already studied array. So array means what? The elements, that means the similar elements can be arranged in continuously. So that elements can be accessed by using index number. So this concept only used in a stag and queue concept. So first we have to study stag. So stag is nothing but it's like a, just imagine it's like a bucket. So that image is like a bucket. So in a bucket we have to insert some elements or we have to delete some elements in a only one end. That end will be called as top. Okay. So the stack is nothing but is a collection of elements can be arranged in an array manner, that means continuously, and also we have to access that element by using index value, and also we have to insert elements and delete the elements in a stack in a only one end. That end will be called as top. Okay. Then now we have to understand one thing. So suppose if any element can be have not placed in a stack means, then what is the value of the top? So we have to say set the elements can be arranged in array format. So that means the first elements can be stored in 0 and second element can be stored in 1 and the third element can be in second position, so and further and so on. So now told, so what is, suppose if no, that means does not have any element can be stored in stack means what is the value of the top? So how can we identify the stack is empty? So this is the main preconditions of before we have to perform some operations on a stack. Okay, so commonly, so then what is that? So suppose the top value is -1 means, so the stack is empty. Suppose if we want to insert the first element into the stack means we have to increment the top and then we will insert the element. Again further and so on, we have to increment the top and push the some element. Again we have to increment the top and push some element. So it can be so on. So before that in a stack we have to perform normally 3 basic operations. So first one is push, second one is pop, and third one is display. So in a previous unit we have to study in a linked list. So same as these 3 operations can be performed in a linked list, but the name can be changed. Here we can say push means, in a linked list we can say that is a insert. So the push means is nothing but is a insert operation, and pop is nothing but it is a delete operation, and display is nothing mean is a traversal. That means what are all the elements in a stack we have to project to the users. So these basic 3 operations can be performed on the stack. So now we have to enter into the first operation, that is push. Okay, so every time we have to perform to the push operations, before we have to check one precondition in a stack. Suppose if a stack is full means how can we insert some elements? So that is not possible. So we have to put some elements in a stack means if we want to insert some element into the stack means before that we will check one precondition. That preconditions will be called as stack full. Okay, then stack full means what? In a stack full, so every operations can be performed, that means write in a functions concept. So here we can write a routine for stack full. So how can we write? Int st full. So here how can we check st full means? So st is nothing but is a stack and full means so the top. So I already told we have to insert every element. We have also increment the top pointer. So suppose if we want to insert first elements means the top value is 0 and second element the top value is 1 and so on, so on, so on. How to the last limit of the top is array. That means the data elements can be stored in array concept. So now have to the array size is n means the maximum limit of top value is top equal to n minus 1. Because suppose the array size is 5 means we have to store in array 0 to 4th location. So only the top value is, can be start from 0 and the maximum value of top is n minus 1. So now we can told in which conditions we will given to check the stack is full or not. When we will say the stack is full, the top value can be reached n minus 1 means the stack is full. Then write a routine in if condition we will give top, that means equal to n minus 1. This is one type of conditions, or in another one method we have to write this condition, that is top greater than or equal to n minus 1. So both is correct one. So now we will check the stack is full means we will check the condition the top value is greater than or equal to n minus 1. Suppose the top value reach the n minus 1 means return 1. What is the meaning of return 1? This is the true. That means the stack is full. Otherwise else return 0. That is false. So based upon the result of this condition, again we have to perform the push operation. So now, okay, so now we have to perform how to perform a push operation. That means how to write a coding for push. So that means so every operations will be performed and write a coding for that by using a function concept. So here we using the void push. That means function concepts. So this is the empty parenthesis. This means is the without arguments. The functions without argument mean. So here, so what is the input for that push operation? The user gives some input. So that can be declared by int item. Okay. Then, so I already told how can we insert some element. So we have to increment the top and then we will push. So already told. So same as we have to write the code for that. So first we have to increment the top. That means top plus plus. Okay. So and then we will push some elements. Where we push in array, the elements can be stored in a stack is like array. So that array where the top pointer will be notified, that place we have to insert some elements. Suppose the pointer will be top value will be denoted by 0 means here we have to insert the elements in array. So same as top equal to 1 means here we can insert some elements. So we have to increment the top and then where the top pointer will be notified that array, that place we have to insert some elements. So top plus plus and then that means tag yes of top equal to item. So what is this is? This is the array in a stack. So suppose if you want to some insert an element means how can we store in a stack? So same as in a array concept. So here S is a stack, that means array, name of the array, and that array we have the top pointer where we notified that the top pointer, that place we have to insert some element. So S of top equal to item. Okay, that's enough. This is the code for push operation. Next, second operation, what is that? It's a pop. So pop is nothing but we have to delete some elements from the stack. So just imagine in a classroom, if you want, I have to told you all or you submit your note, means you have to submit a note in a tables like a one by one is in top manner. This like, so we have to remove the note, means which note we have to write. That means all of you submit your note. So which note I will correct first? So which who are submitted in a last, that note will be corrected by first. That is the last in first out manner. So the stack is working in a last in first out manner. So that is from the concept itself we will know how can we perform the pop operation. That means which element can be inserted recently. That means which element can be inserted last. That element can be popped first. Okay. So suppose the stack we have to perform a push operation continuously. That means we have to insert 4 elements in a stack, means 10, 20, 30 and 40. Now the top pointer where we can be notified. So in a 40. That means 0, 1, 2, 3. That means the top value is 3. So in a stack 4 elements can be stored. The top pointer will be notified the 3. That means third location. So now the pop operations can be performed by what can be told? So which element can be inserted last, that element can be popped first. So why? So every operation, that means push and pop, whatever it is, that both operations can be performed only one end, that end will be called as a top. Then now we told where the top pointer will be notified in a third location. So now which element going to be delete first? So this element will be going to delete first. Okay, so the 40 can be popped first, and then what we can do? So decrement the pointer. So now the top pointer notified which elements? 30. So again we will pop the 30, again we will decrement the pointers. So on, so on, so on. How can we reach the minimum value? So the top value can reach the 0, means again say exit. The pop operations can be exit because the stack is empty. So suppose the stack is empty, means we cannot delete some elements in a stack. Okay, so same as now we told. So before we have to performing a pop operation. So which preconditions we have to check? The stack is empty or not. So we already studied before we have to perform the push operation, we have to check the stack full preconditions. So similarly we have to, before we have to perform the pop operation, we have to check the stack is empty or not. So what is the routine for that? So int stempty. So okay, now so same as, so in which conditions we have to check? How can we know the stack is empty? So when the top pointer reach the -1, the stack is empty. That means if in a stack the first element can be stored in 0th location, means so suppose if the stack is does not consider any element, means the top value is not in a first sections I will told. So in any if any element not present in a stack, means the top pointer will be notified by -1. So now we told in if conditions is, that means if you want to check the stack is empty, in if condition how can we write the routine? So if top equal to -1, return 1. That means so the top value is -1, means the stack is empty. Return 1. Return 1 means true. Else return 0. That means false. The stack is contains some elements. Okay. So before we have to perform the pop operation, we have to check the stack is empty or not. Suppose the stack is empty, means we cannot do the pop operation. Otherwise we can perform the pop operation. Now we have to write the coding for pop operation. So now we have to write the routine for pop. So same as, so every operations can be write in a function concept. So int pop Okay, similar to the push operation. So what is we have to delete some items. So that can be declared by int item. So next what you have to do, so in a stack some elements will be filled by that. So 10, 20, 30 and 40. So where the top pointer will be there in a final element, that means recently inserted element will be noted by top. That means 0, 1, 2, 3. Now the top value is 3. So this is the stack is full. So after performing the push operation, the stack is looking like this. Now we have to do the pop operations. So how do the delete some elements in a stack? So where the top pointer will be notified, that element can be popped and then we will be decrement at the top. Okay, so same as, so first line what does we will write? Top plus plus. In a push operation we have to write first, we have to increment the top. So this line in a first. So here we have to perform the pop first. So where the element, that means which element we have to going to be popped, that will be notified. That means the item equal to yes. That means in array yes of top. Just in this statement we have to notify which element going to be deleted. So we have to notify in stack the top pointer where will be placed, that element will be popped. So this is the meaning of that line. Okay, so after that, so now we can be notified this element we have to delete. If you want to delete means we have to notify this one. So again second step what we have to do, so now we have decrement the top. That's enough. So automatically the top element will be popped. Okay, so now top minus minus, that's enough. This is the coding of pop. Okay, so what we have to learn from this, we have to perform the pop operation. So before we have to perform this, first we have to check the stack is empty or not. Okay, after that we have to perform the pop operation. So in a pop operation, so where the element going to be popped, in this element and this element, this one, no. So where the top pointer will be notified, that element will be popped first, because the stack is lost in first out manner. Okay, so recently inserted node that can be removed first. So only we have to notify which element we have to delete. This is the meaning of that code. So item equal to yes of top. So what is the S? This is the array of the stack name. So yes of top pointer, where the top pointer will be notified. So again top minus minus. So we have to perform top minus minus, automatically that previous element can be deleted. Okay, and so on. So this is the push and pop operation. Again final one operation we have to told display. So display is nothing but we have to show the elements, what are all the elements in a stack to the user. Just we have to print the statements. Okay, so now told where we start to print the elements. So void display, same as every concept will be write in a function manner. So void display. Okay, fine. Next, in array of elements we have to print means in which concept in a C we have to use. Suppose if you want to get the elements, the group of elements, or if you have to project some group of elements, means in C we have to use for loop. Okay, so we already known this concept. So we have to get at a time some group of elements, at a time 10 elements, 20 elements, and we have to project or print 10 elements and 20 elements at a time, means we have to use a for loop. So here we can show like this. In a stack we have to print the 10 elements or 20 elements or other than. So what are all the elements in a stack? All the elements can be printed at a time. So now we have to use a for loop. Okay, for loop. So in a for loop we have used some iterative value I. Okay, so where we have to start to print the elements from here itself or here itself. So we have to, suppose if you know 0 is 1, so 0 is the first element in array, first location in array. So we have to print like this. That means down to up. No. So here now all the elements will be pushed into the stack, means where the top pointer will be notified, top. So we have to project, that means we have to show to the information to the user, means where the element will be taken as a first. So top elements. Okay, so from itself we have to show some elements one by one. So now we have to told the I element will be start from where itself, so top. Okay, so I equal to top, we can fix that value I. Again, okay. Again, what is the maximum limit of I where we have to stop that iteration? So when the I value will be reached the 0 means, again that's enough. The stack elements will be completed. So after that the stack is empty manner. So the I value is greater than or equal to 0. So if we reach a 0 means the stack is completed. So we have to show the elements up to 0th location. Okay, now top to 0. So when we reach, what we can do, we reach top to 0, increment the pointer or decrement the pointer. So here now the top value is 3. So we have to reach the 0 means we have to decrement the value 1 by 1. So now is I minus minus. Okay, that's it. So now print the elements by using a printf statement. So percentage D, comma. So now told, so which element, that means which type of information we have to show? Top or array. So we have to show the top means, so in the top we'll have to show the array location only. Suppose if you print like this, top means it just to show the location. Okay, so in a stack, what all the locations are there, that only be printed. So that is not a result, that is not a correct result. Now we have to print what are all the elements in a stack. So we have to print the array. Okay, so how can we define that array? S of I. Okay, that's it. So this is the display of the stack. So today we have to discuss about what are all the operations in a stack and what are all the preconditions in a stack and how can we data elements can be insert and how can be data element can be pop. What are the style of working manner of stack. So all the things we can just recall and learn.